Hello and welcome to this lecture 5 on applied ergonomics. We were looking at time and motion study in the last lecture. Would like to go forward into the basic procedures which are associated with work study at this stage. So, basically it is a step by step procedure which says that first you have to select the particular job or task or process that you need to study. You have to remember that any big activity related to manufacturing or maybe let us say a unit which caters to a product or a service is associated with several such jobs or tasks. It may run in even close to hundreds of thousands actually, and so the idea is to be able to locate among those tasks those tasks where you feel that there is some wastage involved, or there is something which is going wrong, which is helping in a big way to not create productivity improvement, etc. And so you have to identify some of those tasks. So this comes under the select option. Okay. So out of all the jobs or tasks which have been laid out, you select only probably the few, and there is some Pareto analysis or something you have to use. For example, as you know that the Pareto's law states that the top 80% problems come from only 20% of the reasons. Okay. So the same kind of a analysis has to be carried out as far as the when the jobs are laid out together in order to be able to select those top 20% of the reasons which need to be, or tasks which need to be really maneuvered or transformed, so that it almost about changes the productivity by 80%. So then the question of recording comes, that once these tasks have been identified, then you have to in a very organized manner record all the relevant data which is associated with the task. And in fact, when we talk about time and motion studies, here is where a lot of methods are used for recording the motion sequences involved in a certain task, or even the time scales which are associated with those motion sequences, or in fact trying to indicate motion sequences where some motions contribute to the overall task in terms of value addition, some motions are always there by the necessity to have them, but they are non-value adding, or there are certain motions which slows down the primary motions which would be able to achieve value addition to the product, etc. So there is a very nice classification in this recording scheme itself, where you classify a task to be one which is the main task, one where there is a slowing down effect on the main task, another which is a disabler for the main task. So once that recording is done, then you want to examine. So basically you lay out all recorded tasks in terms of their times, in terms of their motion sequences, and try to record facts critically, and that can be possible by challenging its purpose. Okay. So there are certain questionnaires that I will at the end of this presentation make, which talks about, okay, is the task very important, can it be combined, can the task be occurring at a different place or a different instance of time, can it be carried by the same operator or different set of operators. So these are the sort of questions which would enable the fitting of the right task to the right person at the right time, so that there is an optimization which is going to be there. So this is all a part of the examination process. You have also record facts critically with respect to the place of the task, the sequence of the task, the person involved in the task, the method which is applied for carrying out the task, so on and so forth. So once this examination is done, then you develop, now the iterative process starts into picture. What modification, what alternative do you have in mind to the set of existing tasks which would do a better job in terms of time or motion sequence. So you develop new methods. For example, looking at a certain task structure, you can say that, okay, this task structure seems to be very wasteful, let us develop an alternative structure like this, where there is some difference between the previous task structure and the newly developed task structure in terms of reduction of wasteful motions, or even reduction of time scales associated with the overall task, etc. And so this new alternative, if it works out well, can be treated out as a standard job description or process description for that particular task. And in this manner, for all the 100,000 tasks or more which is there, you do such development of alternate methods. In fact, what I am referring to is again addressing probably most of the tasks, but then again as I told you at the very beginning, that only probably about 20% of such tasks are responsible for contributing to 80% change in productivity. So the first emphasis should be carried out to those 20%, and then it can trickle down the order, and it can be seen whether any further tasks, if treated are really contributing or not. In case they are not, then they can be left alone as such. Okay. So, you do not need to really do it about the whole spectrum, but about those which are really wasteful in nature and contributing a lot to lessening of productivity. So, then you evaluate the results for different alternative solutions and then define the new method, new process, present it to the concerned people, convince them that this is the process through which, if you want to execute the task that you are doing, your life will be better, in terms of productivity, it will be better for the system. You will probably get more paid for doing equal amount of work, okay, because your wasteful mission is now gone. So, those apprehensions, there are a lot of apprehensions which happen when such task planning is done among the basic stakeholders who are the workforce. And one of the reasons that people start debating quite a bit is that when this task motion analysis is carried out, there will be some manpower saving and there will be people who will lose jobs, but that is really not the goal of the overall activity. The overall activity is basically to streamline within the existing framework those people who are coming out of because of not being necessary can be put or deployed in another wing or another operation where maybe it is a new initiative, a new development of the same plant or the same company. So, these issues would always have to be visited and a lot of convincing needs to be done to define the new new method to the concerned people. And then finally, there is an install step, which means the new method and associated equipment needs to be in place. You need to provide training to the concerned staff, so that they can be used to such method, okay, or such implementation of that method. And then there is of course a maintenance issue, that once this new method is in place, you must see that the old methods are not followed anymore and there is a sustained maintenance of this activity. So, this is the basic procedure. So, you basically trying to organize the task structure, take those which are non-contributive in terms of increase in productivity, trying to look at them very critically by recording all details, trying to sort of intervene at every level and see and examine and record what is the weakness, try to eliminate the weakness, develop a solution which would be without those weaknesses, and then trying to evaluate those solutions. Concerned people are empowered to implement those solutions, and then once they are implemented, they have to be maintained, okay. And in fact, whatever training, whatever associated paraphernalia is involved in execution of that new task has to be also in place. So, let us look into details. When we talk about job task process selection, it of course involves the following considerations. One of them is of course economic in nature. It has to be cost effective. Whatever new job task process selection we are making, the process itself should be very cost competitive, and you should check whether or not the work study application would pay, okay. If I do all this work study and at the end of the day the productivity improvement is very minuscule, then there is no use of doing the work study. So, that first job for the management which is implementing the work study is to be able to find out whether their system has enough slack which can be reduced, and it will create enough dent or impact on the overall economics. And so, for this, the key profit giving or costliest operations with largest waste or scrap, that should be attacked first. So, that is why I said Pareto analysis, okay. So, as you know that, let us say for example, if we wanted to look at some operations, operation 1, operation 2, 3, and then let us say look at scrap, you will see that the majority of the scraps would come from probably about only 20% of the operations, okay. So, this is let us say 80, this is about close to let us say 50, and these are some units, let us say, of sequences of machines, and the remaining ones which are there are probably less than 10%, okay. So, such 2 or 3 very important wasteful operations have to be first identified for this work study. Next, bottleneck operations, repetitive operations, repeated material handling operations, they should also be studied, because whenever we are talking about a process which has more than one cycles to be carried out on a regular basis, if it is wasteful, then the wastefulness is adding every cycle of operation of that particular process. So, repetitive processes are the ones which should be most targeted. For example, in an assembly line, a worker which repeats a process for 270 vehicles for assembly is the most susceptible for introducing wastefulness in the system. So, can we really monitor that worker very closely, okay, so that we can see how much waste can be eliminated out of what he is contributing. So, of course, Pareto analysis is a very good descriptor in this category. So, job task selection should also be done in light of technological considerations. So, which means that the analysis involves the application of work study for selection of operations and processes, okay, where new technology, example automation etc., should be introduced. I already told you about something related to a coolant gun vacuuming the coolant system and filling the coolant as the vehicle proceeds. Okay. So, for example, if we were looking at an instance of, let us say, a rear axle being fitted on the underbody of a chassis of the car typically in an underbody operation goes in a hanger, okay, and it goes overhead and the operator is below and he is trying to do various operations to the underbody of the car, okay, in such instances. So, let us say for example, the operator carries the axle which is very heavy, okay, in nature, and he carries it from a rack which is placed aside in a assembly line and goes down to the underbody region, while one worker actually holds the axle close to the underbody of the car, the other goes and tightens the bolts. Now, this is a very wasteful activity. So, if I wanted to automate this whole process, the best idea would be to mount this axle from a subassembly stage, an axle subassembly stage, rather than putting into a trolley. The axle subassembly can be made just adjacent to the underbody assembly, and the axle is assembled by a few workers and supplied through a pallet, okay, or let us say a jig onto which the axle is resting down to the main chassis assembly area, and basically there can be a sort of a lift, you know, it could be a Caesar lift which otherwise is covered on all sides. So, it basically is a safe operation which is operated pneumatically or something. So, the lift comes and aligns as a table to the rack which is supplying, okay, of rollers this pallet. So, the pallet comes into the lift, and then as the axle is loaded onto the lift gets engaged to the hanger of the car and moves along with the car while the axle is lifted, okay, along with the pallet. Okay. So, the axle goes and positions itself, and the only job that the operator is left with is to do the lift operation, and probably one operator can just tighten all the 4 bolts which are there in place to join the axle to the main body. So, this is an automation step. So, this actually has a technological consideration, that how I have innovatively designed something where instead of an effort of 2 people, one lifting the axle, another mounting the axle, we are getting it done through a single person, okay, with using some kind of a automation. So, this is where technological considerations come into picture. There are also human considerations, okay, which is basically involved. The analysis involves location of those operations which present the sources of dissatisfaction or annoyance to the workers due to fatigue or monotony of or unsafe environment, okay, or a work which is clumsy in nature. For example, let us talk about something which is related to paint. Let us say you know, there is a chance, or there is a possibility that during the painting process, because of some small particulate inclusions, there are dust spots which come on the surface of the car body. Now, these are typically analyzed at the painted body OK stage, where the car would go into the assembly line, and just prior to that, and supposing there is such a dust spot which is coming continuously in an area where the repair should be carried out typically by sanding the dust spot away, and then putting, you know, different layers of paints or coats and then baking it through the oven. So, this is a sort of a repair activity which should be offline, but typically these repairs on, if the assembly lines are quite productive in nature and they are associated with many cars per shift, they are done online. And so, let us say we look at the illumination level of such an area, and we see that it is poorly illuminated. So, the operator who is going to look at the dust spot and repair the dust spot is going to be very frustrated because of the lack of illumination. So, the first thing that comes to one's mind is those considerations where can I augment the system in a manner so that it is comfortable for the particular you know, the task provider to deliver the task. Okay. So, in this case extra illumination in the area is pertinent, because that will help to demarcate any defective vehicle from going outside the painted body OK region. So, these kind of considerations are always there when we are talking about doing task selections. Okay. So, we must select the tasks in a manner with consideration given to the economics, the technological constraints, and can we develop a solution, and then also the overall human factors which are involved in doing. So, if there is something where it frustrates the operator, this is of primary importance for us when we talk about developing a motion study, to select those tasks and trying to revisit some of the systems associated with those tasks. How do we perform so that you can record the facts which come out of once the tasks have been selected, come out very concisely, maybe on a single sheet of paper. And so, there are certain tools which are provided by various practitioners, okay, which actually is responsible for fact recording, I would say abridged fact recording on a piece of paper. And these can be related to charts which are based on sequence of processes, or charts which are based on time scales. Okay. The sequence charts could include typically like things like outline process chart. I will just come and explain to you these in more on an individualistic basis just a little bit later, but outline process chart typically includes two different kinds of motion. One is associated with a process, and another is associated with an inspection. Okay. So, you basically laying out the whole process in terms of those where the process contributes to the value, and another is that whatever contribution has been made by the process is being evaluated. So, a process and an evaluation. So, this kind of a outline schematic would lay out what are the different processes and what are the different value let us say evaluating mechanisms which are involved in carrying out a full process. So, a process is described in terms of those symbols. So, there are in fact 5 different kind of symbols which will signify different aspects related to if it is a task, or if it is a inspection task, or if it is something related to the forward motion or something related to a delay. So, I am going to come to that in the next slide, but that is how the outline process chart comes out. The flow process chart is a little more than the outline process chart. It basically looks at not only the process and the evaluation, but also how the flow is going to happen of the material which comes into the process as well as outside the process. Okay. So, this gives you in totality a picture of the whole process of production. And then of course, there are two-handed charts. Two-handed charts typically are related to executing the task in a time wise manner by looking at what your left hand would do and what your right hand would do. For example, if I wanted to take a cover and put it on the top of, let us say, the engine head, and then fit 3 bolts or 4 bolts on this cover to attach to the head. So, typically my left hand would probably do the job of picking up the head cover and then placing the cover over the head. The head is going to come to me from the last station where there was some other manufacturing on the head, and then there would be my right hand which will take about 8 bolts or 9 bolts and put it around this engine head, and then there would be a sort of gun which both the hands would be needed to pull, so that this gun which has 8 different sockets would in a equispaced manner sit on those bolts and try to torque those bolts. Okay. And so, there is some cycle time given till the operator has to use both the hands to hold the gun before the torquing indication comes, and then you release the gun so that the gun goes away by springing action, and once it goes away, hits a limit switch and the gun goes back to your next station. So, till and until this whole process is happening, the gun is being carried along with the engine assembly from one station to another, assuming that the engine is kept on a pallet. And so, what essentially is happening is you are using both hands to do that. So, if I can make a time chart of what my left hand is doing and my right hand is doing, and then maybe introduce some clock times where as a function of time from 0 seconds onwards, I project for 0 to so many seconds this particular operation is done by my left hand, then the right hand comes, or both of them come together. So, this is a way of representing the sequence of operations associated with a certain task. Again, we could have time scale charts which would talk about multiple activity charts or SIMO. SIMO charts are basically related to the same concept of right and left hand, but here the idea is to be recording the time scales independently of the right and the left, okay, so that we could be able to sort of describe the total time involved in doing the sequence of operation. In the earlier case, the two-handed chart would normally be for a sequence in time, okay. So we are using the time scale to record what follows what, okay, without giving an instance of what amount of duration is involved between two operations. But in the SIMO chart, it is the duration which is more important, because we are going to have a time value for all events being done by the left hand and all events being done by the right hand, and record it in that particular manner. So I am going to come and explain this little details. Then there are also some diagrams apart from charts which are used from time to time. For example, I would like to illustrate particularly the cycle graph and the chronocycle graph, where we talk about video filming, okay, of process operations. And video filming could be done with an instance of carrying out some indicator on the hand of a particular person to understand the hand motion, okay. So let it be like, for example, an LED, a small LED which is being carried on the hand, and if the hand moves, the LED moves along with the hand. And in one instance, just by a proper camera shutter control, I could get a flow path of how the hand moves in space, okay. So this according to the whole cycle time of the particular operator. Another instance, I could basically try to shut down the camera as a function of time as the hand propagates. And so between different operations, let us say in one particular task also there are different operations, you could actually get a sense of direction, okay, as the camera shutter closes on as a function of time for between one operation to the next operation. So you get a sense of direction of your hand movement between one operation to the next operation in this way. In this following manner, in an organized manner, you could actually get a very good detailing of how the hands and limbs are moving of an operator in an assembly line with respect to whatever operations he is delivering or recording. So let us look at the first process chart and the symbols involved therein. So typically the American Society of Mechanical Engineering has recommended 5 different symbols which are used for process chart. So they are symbols: the circle related to an operation. This is the main step of the task or job involved in the modification of the change. There is something involved in inspection recorded by a square which checks the quality or quantity of what has been produced in the last step. There is also an arrow symbol which represents the transportation, particularly for movement of persons and materials. There is also a D signal here which represents delays, particularly temporary delays. Temporary delays could happen because of the waiting time. For example, material is there is not online, material has not arrived online, and the operator is simply waiting because he wants the material to come in place before he starts assembling it to the vehicle. So this is more like a temporary delay and immediately has to be resolved. So in fact, that is where the lean manufacturing principles and concepts come. So there is a system of, if you look at how Toyota production system is made, there is a system of andons which are basically calling bells on different stations related to lines, and there are 2 different grades of such andons. One is a yellow battery of light and another is a red battery of light. Red indicates process stoppage, where because of such a criticality like a delay, a temporary delay, a process is stopped, okay. And the yellow battery of light indicates if you know there is no process stoppage, but the process is carrying out with some shortcoming, okay. So this information from station to station is quite highlighted at the highest level, and as a function of time, everybody including the senior most manager in the whole production unit is a witness to what is going on a real time basis on the different production processes, okay, within that system. So delays in that manner can be categorized, and then there are certain permanent delays, and these are more related to material storage issues. For example, let us say there has been some issues related to authorized issue or receipt of materials, okay. For example, a material is coming from a vendor end and there is a compliance issue on that material. There is some quality problem which is there on the material, because of which the material truck is still not being able to offload itself onto the assembly line. So there is some cause because of which a delay is being intentionally made, and they are more permanent in nature, because unless the vendor comes and solves the problem or sends an alternate truck, that material cannot be loaded, okay, onto the assembly line. So these kind of things are actually storage related delays, okay, or permanent delays. And so the idea is that a process chart should be able to, in terms of all these symbols, give you an idea of the sequence of operations which is involved in such a process. Okay. So, for two parallel events, both are shown in one joint or combined symbol. For example, if I had an operation inspection all at the same station, let us look into a flexible manufacturing line associated with the machine shop. So, you have a couple of CNC machines and there are certain automated inspection stations which are within those CNC machines. So, I can say that if I am machining an engine block, for example, and I wanted to hone the internal surface of the engine cylinder, there is a gauge which would use online, which is a pressure gauge or an air gauge. Let us say we insert the gauge, there is a back pressure recorded through which you could see what is the surface finish of the machining operation. This is actually done within that CNC setup. Okay. So, in such kind of automated 100% inspection equipments aligned to a certain process, you know, it can be represented through these kind of mixed symbols, where a production and inspection is carried out simultaneously on 100% inspection or inspected to be inspected parts. Okay. So, you can jointly show such symbols for even inspection and transportation. For example, there may be up to number of cases where you are able to inspect let us say a door, okay, while transporting it. Okay. So, for example, there is a door from a sub-assembly which comes and it is being fed to a conveyor through which it comes to the main line to get installed, and in between there are certain image recorders which would analyze if the door has a dent. So, this is actually an inspection being carried out along with a transportation. So, you could actually have a mixed symbol of a square and an arrow representing that. So, this way you could have various symbols where multiple operations are carried out together, or even processes are either operation, inspection, transportation, delay or storage related representations. So, as I told you earlier, outline process chart typically combines of only these two symbols, where there is a process and an inspection. So, it provides the overall picture of the process, job or task, okay, and primarily it is a sequence of operations used by any manufacturing engineer to understand that what is being done in what particular station. Okay. So, it is like just more giving an information to the manufacturing engineer, and in fact one has to remember that if you lay out everything together like this on one particular chart for a certain process, it may be very conveniently able to get identified in terms of which areas are the ones where you should really focus, okay, if there are time scales attached to such representations. So, I will like to conclude here today's lecture, but in the next lecture I would give a little more details on SIMU charts and also how motions time study could be done through techniques like cycle graph or chrono cycle graphs. So, as of now, thank you very much and goodbye.